Welcome back to Quantitative Inquiry for Public Managers. This week we're going to talk about conceptualization, operationalization, and measurement scales. Let's first take a look at this abstraction letter that we learned last week and refresh our mind about the process of quantitative analysis. In general, quantitative analysis starts from theory. And from theory, we develop hypotheses, which is a relationship between different concepts, and then we collect the data from observables to examine the hypothesis. So there's a question is that because concept or hypothesis, they are abstract, we cannot directly observe a concept or hypothesis. The problem we face is that how to measure our concept so that we can collect the data to test it. That's what we're going to discuss in this week. We first have to understand what the concept means, how to define a concept. That's what we call the conceptualization process. And then second, we have to find our way to measure it, to measure the concept. And that's the operationalization process that we're going to discuss. So this week we're going to focus on three things. The first is the conceptualization process, which is the process of defining a concept. What do you mean by talking about this concept? And the second thing is to operationalize a concept, how to measure a concept. And third is about the measurement scale, different types of measurement scales. Last week when we discussed concepts, we know concepts are building blocks of theory. They are abstract things. They are generalized ideas about classes of objects, occurrence, attributes, so on and so forth. When we talk about these abstract things, abstract terms, we have to understand, we have to specify exactly what we mean and don't mean by the terms we use in our research. And we cannot research things until we know exactly what they are. A lot of times, concepts may have multiple dimensions. They may have multiple aspects. We have to specify which aspect, which dimension we include this into our research by using this concept. For example, we want to study whether employee empowerment has a positive impact on customer satisfaction in healthcare sector. Before we can collect data to answer this research question, we need to conceptualize and operationalize employee empowerment. So first, what do you mean by employee empowerment? Second, how to measure this concept of employee empowerment. Another example. If you want to study what factors contribute to high school violence, then we have to understand what exactly we mean by high school violence, because this concept may have different aspects. They may have different dimensions. By using the term high school violence, do we mean only use of weapon? Or you mean both use of weapon and inappropriate physical contact in high school? Or you may also include the dimension of verbal abuse. So you have to make it clear to all your readers and your researchers and your peers. What do you mean exactly by using this term, high school violence? Before you can collect the data to test your hypothesis, there are several steps you have to go through before you can collect your data. The first step is to define your concept. That's the conceptualization process. In this process, you define the terms you use in your research, especially those important to your research. And this process begins by asking people around to describe what they mean when they use these terms. And you can consult experts. You can also resort to the previous studies to see how they define these terms, these concepts. And when you come to an agreement, This whole process is called the conceptualization process, and the result of this process is a concept. The next step is operationalization. An operationalization definition specifies exactly what you are going to observe and how to do it. Basically, it turns your concept into a directly observable and measurable variable. It's a description of the operation that we will undertake to measure a concept. So basically, this process, the operationalization process, just tells you how to measure your concept. You have many ways to operationalize your concepts. You can develop separate measures for each dimension, if the concept contains multiple dimensions. You can develop a single set of measures that encompasses all dimensions, and you can also develop a single measures. Okay, so let's think about the example of high school violence. If you want to operationalize the high school violence concept, which means that you want to measure high school violence, you can develop a single measure by asking your respondent perceptions on high school violence. That would be develop a single measure for all dimensions. Or you can develop a separate measure for each dimension. For example, let's think about you define your high school violence to include 3 dimensions of high school violence: verbal abuse, use of weapons, and inappropriate physical contact. For each dimension, for example, for use of weapon, you can use how many times has been reported to the demonstration of use of weapon in this high school. And for the inappropriate contact, you can also look at the administrative data to see how many times it has been reported for inappropriate in physical contact. So would be the dimension of verbal abuse. Or you can develop a single set of measures that encompasses all the dimensions. Okay, you just make sure you include all dimensions you define for this concept, but you don't have one measure for each dimension, but instead the whole set of measures encompass all dimensions. This slide shows example questions of assessing dimension 2 of high school violence. You can ask this following question to get the result to measure dimension 2 of high school violence. Please tell me which of the following you experienced in or around school during the last months which were not part of a normal sport activities. I was involved in a fight or scuffle. I was physically injured in a fight or scuffle. I was pushed or tripped by someone who I believe tried to injure me. I was touched sexually in ways that were not wanted by me. I was struck by someone with an object such as a stick or stone. Now let's take a look at some examples of how do you measure a concept, how do you operationalize a concept. The concept of socioeconomic status. Can we measure this concept using only the dimension of total family income during the last 12 months? Probably not, because this is only one dimension. We measure the economic status dimension. But socioeconomic status has another dimension of social status. For example, you can measure the social status as using the highest level of school you completed. What would be the problem of missing one of these dimensions? The result would be not reflecting this concept correctly, not measuring this concept correctly. Okay, you only capture either the dimension of social status or economic status. Neither is sufficient. If you operationalize badly, you will end up not studying what you want. For example, if you want to operationalize success in career by looking at a paycheck, only, what would be the problem? Obviously that the paycheck itself does not really measure the success in career. For example, those in private sector usually have a large amount of paycheck than those working in the public sector. But it does not mean those working in the private sector actually will have a better success in career than those in public sectors. They're just not comparable, and paycheck itself cannot measure this concept sufficiently. Now we have to know how to conceptualize and operationalize the concept. The next question for us is to determining the measurement quality. How do you know whether your measure is good or not? How do you know whether you have a good operationalization definition? And there are two criteria you can examine to determine the measurement quality. The first one is called the reliability, how consistent your measurement is. And the second criterion is called the validity. That is the extent to which the meaning of the concept under investigation is captured. And you have face validity, content validity, criterion related validity, and construct validity that we're going to explain in more detail. The measure must be reliable. What do you mean by reliable? Think about the reliability of a scale. If you step on the same scale in a short time, and it does not vary much in terms of the result of your weight, then we say it is a reliable scale. The measure of a variable is the same. If a measure yields the same result every time, it does not depend on who is collecting the data or when the data is collected, then we can say that it is a reliable measure. So in that sense, reliability means stability over time. And the reliability suffers when respondents or researchers have to interpret. For example, if you want to collect income level of the respondents using the questionnaire, then you ask whether your income level is high, low, or medium. Using this question to collect the data of respondents' income level could be problematic. Why? Because the respondents may have to interpret, is subject to interpretation for both the respondents and researchers. Different respondents may have different understanding about high, low, or medium in terms of their income. For example, 80,000 per year income may be high for me, but that's definitely not high for Bill Gates. So when you ask the question whether the income is low or high or medium, is subject to interpretation. Different person may have different interpretation about the level, and as a result, that means different things for different respondents and different researchers. So it is not reliable. One approach to improve the measure's reliability is to use objective scales. Objective scales are always more reliable because they allow for little interpretation. Using a fixed response format usually helps, because researchers does not have to interpret what the respondents mean. For example, you can use multiple choice, you only have several choices you can choose from, and the choices are clear to both the respondents and the researchers. You can also use Likert scales. Likert scale is such a design. As shown in this slide, you ask to what extent you agree or disagree the following statements. First question may be, I enjoy coming into work each day. And you have to answer whether you strongly agree, neutral, disagree, or strongly disagree. And as you can tell from this design, neither the researchers or the respondents will have to interpret the answer. As a result, you will have a reliable measure. that's not subject to interpretation. The second dimension for evaluating the quality of a measure is its validity. Validity refers to the extent to which an empirical measure adequately reflects the meaning of the concept under investigation. So you can look at it as a scale, the degree to which it measured what it is supposed to measure, whether the measure truly reflects the meaning of the concept. As referred earlier, you can evaluate the validity of a concept measure from different perspectives. You can look at its face validity. That means how a measure conforms to our common agreement. For example, measuring the religiosity of a person using the frequencies of its attendance at religious service is certainly a valid measure. Why? Because it conforms to our common agreements that the more frequent you attend a religious service, the higher degree of religiosity you have. The second type of validity is called content validity. Content validity considers how much a measure covers the range of the meanings included in the concept. For example, when we try to measure the student violence, and if it is important concept and you miss one of the three dimensions that we discussed earlier. For example, if you cover only inappropriate physical contact and use of weapon, but ignore the verbal assault, verbal abuse, then you may fail to cover all the range of the meaning of this high school violence concept. So as a result, you're violating the content validity by using the measure of only two dimensions. Both face validity and content validity look at the validity from an internal perspective. They are internal criteria. But criterion-related validity look at the validity from an external perspective. Sometimes it's also called a predictive validity. Our measure predicts performance on external criterion. For example, if you want to evaluate SATs as a measure for future academic performance, you can examine how SAT results predict academic success at university. If it did a great job in predicting the university success, then it is a good measure for future academic performance. The final type of validity is called construct validity. Construct validity closely ties into the theoretical underpinnings of the concept. This type of validity is based on the logical relationship between variables. It actually asks the question, does the instrument actually measure the concept or the construct? It's most difficult to achieve, but it's also most important, because a measure lacking in construct validity is almost useless. Let's finally sum up the discussion of validity and reliability using these three diagrams. The first graph shows you a reliable but not valid measure. So a valid measure means that you're shooting at the center of the target. You capture the essential meaning of your concept. As shown in this first graph, you have a reliable measure, because every time you shoot at the consistently area, the same area. But your measure is not valid because you're not shooting at the center of the target. You're not capturing the essential meaning of the concept. And the second graph shows you a valid but not reliable measure. You're shooting at the center of the target, but it's not consistent. Your shooting is not consistent. It's spread out in a large area, a large range. A third graph shows you a valid and reliable measure. That's what we try to achieve. Every time you shoot at the same area consistently, and you're shooting at the target, the center of the target, you're capturing the right meaning of the concept. The final topic we want to cover in this module is the level of measurement. or the scale of variables. We have four types of scales: nominal scale, ordinal scale, ratio scale, and interval scale. To understand the meaning of these different types of scale will help us to understand the nature of a variable, and that help us to determine what type of method we're going to use for different types of variables, for different scale of measurement. Now let's watch a video to help us understand this different level of measurement.
Before we can conduct a statistical analysis, we need to measure our dependent variables. Exactly how the measurement is carried out depends on the type of variable involved in the analysis. Different types are measured differently. To measure the time taken to respond to a stimulus, you might use a stopwatch. Stopwatches are of no use, of course, when it comes to measuring someone's attitude towards a political candidate. A rating scale is more appropriate in this case, with labels like very favorable, somewhat favorable, etc. For a dependent variable such as favorite color, you can simply note the color word, like red, that the subject offers. Although procedures for measurement differ in many ways, they can be classified using a few fundamental categories. In a given category, all of the procedures share some properties that are important for you to know about. The categories are called scale types, or just scales, and are described in this section. There are four basic scales of measurement: nominal, ordinal, interval, and ratio. When measuring using a nominal scale, one simply names or categorizes responses. Gender, handedness, favorite color, and religion are examples of variables measured on a nominal scale. The essential point about nominal scales is that they do not imply any ordering among the responses. For example, when classifying people according to their favorite color, there is no sense in which green is placed ahead of blue. Responses are merely categorized. Nominal scales embody the lowest level of measurement. The next highest scale of measurement is ordinal. The ordinal scale is used when one wishes to name or categorize, and the order is meaningful. Let's look at an example. A researcher wishing to measure consumers' satisfaction with their microwave ovens might ask them to specify their feelings as either very dissatisfied, somewhat satisfied, or very satisfied. The items in the scale are ordered, ranging from least to most satisfied. This is what distinguishes ordinal from nominal scales. Whereas nominal scales don't allow comparisons in the degree to which two subjects possess the dependent variable, just this kind of comparison is possible with ordinal scales. For example, our satisfaction ordering makes it meaningful to assert that one person is more satisfied than another with their microwave ovens. Other examples of variables measured at the ordinal level are military rank, private, lieutenant, captain, general, etc., and class ranking, first in class, second in class, and so on. Ordinal scales fail to capture important information that will be present in the other scales we examine. In particular, the difference between two levels of an ordinal scale cannot be assumed to be the same as the difference between two other levels. In our satisfaction scale, for example, the difference between the responses very dissatisfied and somewhat dissatisfied is not necessarily the same as the difference between somewhat dissatisfied and somewhat satisfied. Nothing in our measurement procedure allows us to determine whether the two differences reflect the same difference in psychological satisfaction. Statisticians express this point by saying that the differences between adjacent scale values do not necessarily represent equal intervals on the underlying scale giving rise to the measurement. In our case, the underlying scale is the true feeling of satisfaction which we are trying to measure. What if the researcher had measured satisfaction by asking consumers to indicate their level of satisfaction by choosing a number from 1 to 4? Will the difference between the responses of 1 and 2 necessarily reflect the same difference in satisfaction as the difference between the responses 2 and 3? The answer is no. Changing the response format to numbers does not change the meaning of the scale. We are still in no position to assert that the mental step from 1 to 2, for example, is the same as the mental step from 3 to 4. The next highest scale of measurement is the interval scale. As you probably noticed, each successive scale builds upon the qualities of the lower scales, adding additional information. Interval scales are numerical scales in which intervals have the same interpretation throughout. So, the interval scale names or categorizes, the order is meaningful, and the intervals are equal. As an example, consider the Fahrenheit scale of temperature. The difference between 30 degrees and 40 degrees represents the same temperature difference as the difference between 80 degrees and 90 degrees. This is because each 10-degree interval has the same physical meaning in terms of the kinetic energy of molecules. Interval scales are not perfect, however. In particular, they do not have a true 0 point, even if one of the scaled values happens to carry the name 0. The Fahrenheit scale illustrates the issue. 0 degrees Fahrenheit does not represent the complete absence of temperature, the absence of any molecular kinetic energy. In reality, the label 0 is applied to its temperature for quite accidental reasons connected to the history of temperature measurement. Since an interval scale has no true 0 point, it does not make sense to compute ratios of temperatures. For example, there is no sense in which the ratio of 40 to 20 degrees Fahrenheit is the same as the ratio of 100 to 50 degrees. No interesting physical property is preserved across the two ratios. After all, if the 0 label were applied at the temperature that Fahrenheit happens to label as 10 degrees, the two ratios would instead be 30 to 10 and 90 to 40, no longer the same. For this reason, it does not make sense to say that 80 degrees is twice as hot as 40 degrees. Such a claim would depend on an arbitrary decision about where to start the temperature scale, namely, what temperature to call 0, whereas the claim is intended to make a more fundamental assertion about the underlying physical reality. The ratio scale of measurement is the most informative scale. It is an interval scale with the additional property that its 0 position indicates the absence of the quantity being measured. You can think of a ratio scale as the 3 earlier scales rolled up in one. Like a nominal scale, it provides a name or category for each object. The numbers serve as labels. Like an ordinal scale, the objects are ordered in terms of the ordering of the numbers. Like an interval scale, the same difference at two places on the scale has the same meaning. And in addition, the same ratio at two places on the scale also carries the same meaning. An example of a ratio scale is the amount of money you have in your pocket right now, 25 cents, 55 cents, etc. Money is measured on a ratio scale because, in addition to having the properties of an interval scale, it has a true 0 point. If you have 0 money, this implies the absence of money. Since money has a true 0 point, it makes sense to say that someone with 50 cents has twice as much money as someone with 25 cents, or that Bill Gates has 1,000,000 times more money than you do. What level of measurement is used for psychological variables? Rating scales are used frequently in psychological research. For example, experimental subjects may be asked to rate their level of pain, how much they like a consumer product, their attitudes about capital punishment, or their confidence in an answer to a test question. Typically, these ratings are made on a 5-point or a 7-point scale. These scales are ordinal rather than interval scales, since there is no assurance that a given difference represents the same thing across the range of the scale. For example, there is no way to be sure that a treatment that reduces pain from a rated pain level of 3 to a rated pain level of 2 represents the same level of relief as a treatment that reduces pain from a rated pain level of 7 to a rated pain level of 6. In memory experiments, the dependent variable is often the number of items correctly recalled. What scale of measurement is this? You could reasonably argue that it is a ratio scale. First, there is a true 0 point. Some subjects may get no items correct at all. Moreover, a difference of 1 represents a difference of 1 item recalled across the entire scale. It is certainly valid to say that someone who recalled 12 items recalled twice as many items as someone who recalled only 6 items. Number of items recalled is a more complicated case than it appears at first. Consider the following example in which subjects are asked to remember as many items as possible from a list of 10. Assume that there are 5 easy items and 5 difficult items. Half of the subjects are able to recall all the easy items and different numbers of difficult items, and the other half of the subjects are unable to recall any of the difficult items and remember different numbers of the easy items. Some sample data are shown here. Let's compare the difference between subject A's score of 2 and subject B's score of 3 with the difference between subject C's score of 7 and subject D's score of 8. The former difference is a difference of 1 easy item. The latter difference is a difference of 1 difficult item. Do these two differences signify the same difference in memory performance? We are inclined to respond no to this question, since only a little more memory may be needed to retain the additional easy item, whereas a lot more memory may be needed to retain the additional hard item. The general point is that it is often inappropriate to consider psychological measurement scales as either interval or ratio. Why are we so interested in the type of scale that measures a dependent variable? The crux of the matter is the relationship between the variable's level of measurement and the statistics that can be meaningfully computed with that variable. For example, consider a hypothetical study in which 5 children are asked to choose their favorite color from blue, red, yellow, green, and purple. The researcher codes and tabulates the results as shown in the displayed table. This means that if a child said her favorite color was red, then the choice was coded as 2. If the child said her favorite color was purple, then the response was coded as 5, and so forth. Consider the hypothetical data displayed in this table. Each code is a number, so nothing prevents us from computing the mean code assigned to the children. The mean happens to be 3, but you can see that it would be senseless to conclude that the average favorite color is yellow, the color with a code of 3. Such nonsense arises because favorite color is a nominal scale, and taking averages of its numerical labels is like counting the number of letters in the name of a snake to see how long the snake is. Does it make sense to compute the mean of numbers measured on an ordinal scale? This is a difficult question, one that statisticians have debated for decades. You will be able to explore this issue yourself in a simulation and reach your own conclusion. The prevailing, but by no means unanimous, opinion of statisticians is that for almost all practical situations, the mean of an ordinally measured variable is a meaningful statistic. However, as you will see in the simulation, there are extreme situations in which the mean of an ordinally measured variable can be very misleading.